magnetic field due to a circular conductor. Uh, let's consider a circular current carrying conductor. Okay, it is the conductor which carries a current I placed in the xy plane. Okay, that is at the surface of this diagram. Okay, uh, here the axis which is coming out of the surface is z. Now, using biot-Savart's law, we can define the magnetic field density dH vector is I by 4 pi dl cross AR divided by R square or IDL cross R vector divided by R cube. Here we need to find the dl, R vector and R cube. Okay. So here we are having the dl element along the pi axis, So this is the pi axis. Okay. So here this dl is along a pi vector, and the small differential element is d pi and it is angle, so we are including the metric. So dl is rho d pi a pi. The distance vector r vector is 0 0 h. Okay, from point p to the distance of point is. Okay, so here we are having rho pi z is 0 and this point dl may be here or here or here, so we are considering this one as some constant or 0. So r vector is 0 0 h minus rho 0 0. So you will have minus rho a rho vector plus 0 a pi vector plus h a z vector. From this you can calculate r vector is square root of rho square plus 0 square plus h square, that is square root of rho square plus h square. Now let's calculate the cross product of dl and r. We know that dl is rho d pi a pi and r is minus rho a rho plus h a z plus h a z. Here in order to compute the cross product of vectors in cylindrical coordinates, let's take the vectors a rho vector, a pi vector, a z vector. Okay, if you make cross product of these two, you will get this in the forward direction. If it is in this direction, you will have minus ac. Okay, so here you are having a pi, here you are having a rho. So rho into rho, a into minus, so you will have minus rho square d pi a pi into a rho in the reverse direction. So you will have minus az vector, minus minus will cancel. So you will have d square d pi, sorry, rho square d pi az vector for the first product. Similarly, for the second, rho h d pi a pi into ac, a pi cross az, so you will have a rho. Okay, so rho h d pi a rho for the second, and for the first it is rho square d pi ac. So you will have rho h d pi a pi vector plus rho square d pi ac vector. Okay, by following these two rules. Now let's apply this dl cross r, that is equation 4, and r, that is equation 3 in equation number 1. So you will have dh is I by 4 pi, here it is r square, so r square is rho square plus h square power 3 by 2 rho h d pi a rho vector plus rho square d pi ac vector. Here dh vector is dh rho a rho vector plus dhc az vector. Okay, so it is having two parts with some constants. Let's try to split this one into two parts with along a rho and along a pi. So d pi is having two parts. The magnetic field density is having two components. One is along rho vector and another one along z vector. Okay, and the field component rho vector are diametrically opposite field dhp, dh rho from dl dash. If you observe the diagram carefully, okay, so from this point you will have some field, okay, dh vector dH vector, it is having two components. One is dH rho, another one dHc. Similarly, the point dl dash, suppose this one is P, we are having, sorry, this one is some observation point Q, diametrically opposite point Q dash also will produce a field which is also having dP, sorry, dH rho and dHz, and the dHz and dH dash z are both are the same direction, so they will get added up, but uh, the component dH dash rho and dH rho are exactly in opposite direction. Okay, so the same current is flowing here and here, so the time the magnitude also same, so this one will cancel this one, so you will have field only in the z direction, not in rho direction. Okay, so this component dH rho simply vanishes due to minus dH rho from dl dash. Okay, so the dH will have only the AC component, this one simply becomes 0. Okay, and here you will have one from the dl element, another one from dl dash, so you will have two components add up at the observation point. Okay, so dH is 0 plus dHz Az, that is dHz Az. Okay, so dHz is I rho square d pi Az by 4 pi into rho square plus square power 3 by 2. Now, if you want to the total field, then you have to integrate. So actually is pi interval pi equals 0 to 2 pi dHz dAz, just substitute this one here. So you will have uh, z is the d pi is the integrating quantity. So the remaining are constants. Take it out. So I rho square by 4 pi rho square plus its square power 3 by 2 Az integral pi to 0 to 2 pi d pi. Okay. So you'll have 2 pi running from 0 to 2 pi. So I rho square 2 pi divided by 4 pi rho square plus its square power 3 by 2 Az vector. So H vector is I rho square. If you cancel the common terms in the equation, then what you will get, you can cancel the pi 2 4 by 2, so you will get I rho square divided by 2 rho square plus square power 3 by 2 Az vector. So at the center of the loop, okay, so if you want to calculate field at this point, P will be here at the time, the H will be 0. So if you substitute H is 0, H vector is I by 2 pi. Okay, Az vector, how we are getting I rho square divided by 2 into rho square plus 0 power 3 by 2 Az vector. This 2 will cancel, rho square, so you will get I by 2 rho. So at the time the field will be like this. Okay, so in one side, say suppose you are having point dl here. Okay, so at the point you will have a circulating field like this. Okay, circulating field like this, I mean field is in this direction. Okay, and in the diametrically opposite point, okay, here you will have field in the opposite direction. Okay, so it will be in this direction. Okay, uh, like this. Okay, so this one is more or like a magnetic dipole, okay, with fields originating from one point and ending at another point. Now let's have some problems based on this. Okay, a circular loop is located on x square plus y square equal to 9 at z equal to 0 carries a direct current of 10 amperes along a pi vector. Determine h vector at 0, 0, 4 and 0, 0, minus 4. In the previous derivation, we have derived h vector is I rho square by 2 rho square plus square 3 by 2 AC. Okay, so here I is given, that is 10 amperes, and rho is given 3. Okay, s square plus y square is rho square, the radius. Okay, so rho square is 9, so rho is 3. So at 0.004 means h is 4. Just substitute 10, 3, 4 in this equation, you will get h vector 10 into 3 square divided by 2 into 9 plus 16, 3 by 2 az, that is 0.36 az. If h is replaced by minus h, as per biot-Savart, z component h remains same due to axial symmetry. So you will have the same. Okay, here you have h square. So minus 4, if you substitute, you will get the same quantity. Okay. Uh,